Hi, this is trimester 2, day 18, related rates 4. We're just continuing to build on the stuff we've already done, but this problem just goes a little bit more in depth, something a little bit more to think about. So suppose your liquid is being cleared of sediment by pouring it through a cone-shaped filter as shown below in figure A. We can think about a coffee filter. Assume that the height of the cone, the plastic outside cone part, is 16 inches, and the radius at the base of the cone is 4 inches. Sometimes people don't like the fact that the base is at the top, but the wide part of the cone is considered the base. Doesn't matter really which direction the cone is oriented. If the liquid is flowing out of the cone at a constant rate of 2 inches cubed per minute, what's changing there if the liquid is flowing out? The volume is changing. The volume of the liquid is changing at 2 cubic inches per minute. So let's get that down. Our dV dt is equal to 2 cubic inches per minute. Now, is that volume increasing or decreasing? If the liquid is flowing out of the cone, the volume is decreasing, so our dV dt is negative. We want to find how fast is the depth of the liquid decreasing when the level is 8 inches deep. Well, if we look at our picture, so in this problem we didn't have to draw our own picture. It was given for us. So that black box that we've used before, this part is here. So we want to consider that we've got liquid inside this cone that is only coming up this high. So while our entire cone might be 16 inches deep, the height of our liquid is only y inches deep, and the radius of our liquid is x inches. So if we want to find how fast the depth of the liquid is decreasing, we're trying to find dy dt when the level is 8 inches, when y equals 8 inches. So we're talking about volume of the cone. We're going to need that equation for volume of a cone. This is an equation that I will provide for you. If it's circles, squares, rectangles, and then I'd be expecting you to know those in our trig relationships. But volume of cone, volume of sphere, I will be providing for you. So the volume of a cone is V equals 1/3 pi r squared h. So if we were to look that up, so the standard equation V equals 1/3 pi r squared h comes from a geometry book or if you did a Google search. But we don't have r's and h's in our diagram, so we need to change it to the variables that we do have. So V equals 1/3 pi x squared, and the height of our liquid is y. So again, we want to use the x and the y because we're talking about the volume of our liquid, not the volume of the entire cone. Okay. Now, here's where the tricky part comes in this problem. If we take the derivative right now, and we know from doing all of these other related rates problems that the next thing we want to do is take a derivative so that we'll have a dV dt in our equation, we'll have a dy dt in our equation. If we take the derivative right now, and we could go ahead and do that, but we'd end up at a stopping block. So I'd like you to think a little bit about what's going to happen when we take the derivative. We see that if we took the derivative as it is right now, we would have to use a product rule. And when we take the derivative using that product rule, we'd have our first times the derivative of the second, which would give us a dy dt, which is fine because that's what we're trying to find. But then we would have plus the second times the derivative of the first. And when we take the derivative of this first, we would end up with a dx dt in our equation. We don't know anything about dx dt. It's not one of the things that's given. It's not what we're asked to find. It would be an extra thing in there that we don't have a way to find out from our information that's given. So our new thing for today is to realize that we have too many variables here. I don't want to have an x in my derivative equation, so I need to find a way to eliminate that x. So what I'm going to do is I'm going to come back over here and look at those similar triangles like we had in yesterday's problem. We've got this similar triangle of x and y as 4 is to 16. So we can say that 4 is to 16 as x is to y. We can say that 4y equals 16x. And if I don't want the x over in my equation that I set up to, that I'm using as my basis for solving this problem, I'm going to solve for x here and say that 4 over 16y equals x, or x equals 1/4 of y. Well, if x equals 1/4 of y, let's come back over to this equation. And we've got v equals 1/3 pi, so I'm going to make that into pi over 3. And then my x, I'm going to replace with this 1/4 of pi, 1/4 of y, 1/4 of y times, and then square that, and then the other y. So here's my pi over 3. My x squared, if x is 1/4 of y, I'm going to need to square it, and then times that y. So again, I just want to tidy up. V is equal to pi over 3. This is 1/16 of y squared times y. So v equals pi over 48, or I'm even going to leave it as 3 times 16, y cubed. So far, so good? Okay. So the next thing I'm going to do is take a derivative. dv dt equals, I'm going to multiply this 3. I've got 3 times pi over 3 times 16 y squared dy dt. So I had kind of peeked ahead and knew that that 3 was going to cancel, so that's why I didn't write that as a 48. If you did, no big deal, it would have canceled out anyway. So dv dt equals pi over 16 y squared dy dt. Now I can go ahead and plug in some values. I know that dv dt from up above is -2. Equals pi over 16. And they asked us to find this when y is 8. And they're asking us to find dy dt. So that should stay in there as a variable. So let's see, we've got -2 equals pi times 64 over 16 dy dt. Or dy dt equals -2 times 16 over 64 pi. So I got that by multiplying each side by 16 over 64 pi. So let's see, coming back here, dy dt equals -1 over 2 pi. 2 times 16 is 32. 32 over 64 is 1 over 2. So that's approximately -0.159 inches per minute. The y is measured in inches, time is measured in minutes. So our answer is the units are in inches per minute. Okay, so the big thing here, what's our learning point for today, is that at this point right here, I had too many variables. If I took the derivative there, I would end up with a dx dt. I don't have anything about dx dt. So I wanted to use my sidebar over here to find a way, and I use the similar triangles, to find a way to replace x, find a substitution for x. So I found x in terms of y and put that 1/4 y in where this x is. Simplified my equation, and now once it's simplified, I can go ahead and take the derivative. After I take the derivative, I can look at at this point in time, when y is 8, I can then solve for dy dt. So again, hope this helps.